Hello, chemistry fans, and welcome your faces back to Chemistry 1032 problem-solving session here at the Academic Success Center. I am your host, Dr. Russell Betts, and I'll be leading you through this problem. So let's just jump right into it. All right, Chapter 6, Problem 7. Name the following compounds. Ooh. Are you seeing what I'm seeing? We've got a mixture of covalent and ionic. He wouldn't do that. Oh, yes, I would. I would definitely do this on an exam. I would throw in the ionics and the covalents together to see if you can tell them apart. So this question's a little bit tougher. Not only do you have to be confident in how to name ionic compounds and covalent compounds, you also have to know how to tell them apart. Well, it's easy. It's easy. First of all, if you have a metal in your formula, at least in Chemistry 1032, if there's a metal in your formula, it's ionic. Just assume it's ionic 99.999% of the time, especially in 1032, you will be correct. There's one exception. Actually, it's the bottom example here. I'm going to show you this one. I'm going to take some time on this one at the bottom to make sure you're clear on why this one at the bottom is actually ionic. Okay? And I'm going to explain to you why. But if there's a metal in the formula, it is ionic. So let's make a little note. Right beside, maybe to the left here. We'll put an I for ionic and a C for covalent. Let's find the ionics first. They're the easy ones. So here we have Fe. Fe is a metal, so this is going to be ionic. So put an I, just I for ionic. Aluminum. Aluminum is a metal. It's ionic. CO. Now this is not cobalt. This is not cobalt. It's capital C, capital O. Cobalt is capital C, lowercase o. This is not cobalt. This is carbon and oxygen. Carbon is a nonmetal. Oxygen is a nonmetal. This is covalent. So put a C. C, not for carbon, but for covalent. Sodium. Sodium is a group 1 metal, so that is ionic. Nitrogen and oxygen. Nitrogen, nonmetal. Oxygen, nonmetal. This is covalent. Tricky. You can put a T for tricky if you like, but this is NH4. If you look on your formula sheet for your polyatomics, you will see it on that list. This is NH4 plus ammonium. This is actually ionic. We'll go back to this one, and I'll go a little bit more in depth onto why that's ionic. Okay, so let's be very careful here. Now let's think back to the ionic stuff. What's special about some of the metals? They're transition metals. If you're a transition metal, you have to have the polyatomic. Or pardon me, you have to have the Roman numeral, not the polyatomic. So now, iron. Iron is a transition metal. So you have to give it a Roman numeral to tell the reader what the charge on the metal is. So let's look at this formula carefully. We have iron and CO3. CO3 is a polyatomic ion, and it has a -2 charge. We know that the formula must be balanced, and that is the charges must equal. The negatives and the positives have to equal each other out. The formula tells us we have 1 iron and 1 CO3. We know the CO3 brings a -2 to the formula. So the iron must have brought a +2 in order for this formula to work. So the iron has a charge of +2. So this will be iron, Roman numeral 2, carbonate. Iron 2 carbonate, because the charge on the iron was +2. If you still don't know what I did or you can't figure that out, pause the video, call for a tutor at the Academic Success Center. Figure that out. This is a hard one. Figure it out. Don't let it slip. In fact, don't even go to the next one until you have that straightened out. All right. Next, we have a polyatomic ion again, and we have a metal. Okay, no problem for us. We are smart. Now, aluminum is a group 13 metal. It can only be +3 if it's an cation, so don't worry about Roman numerals. Roman numerals are only needed for transition metals, tin, and lead in chemistry 1032. So this is just aluminum. That's the polyatomic nitrate. That is in the list of polyatomics that I will give you on the exam. But by the time the exam rolls around, you will have seen nitrate so many times that you will have it committed to memory. This is covalent. Covalent molecules follow a little bit different set of rules. We have to tell the reader now how many of each atom we are dealing with. So this is going to be carbon monoxide. All right, here's an easy one for us. Throw an easy one at us. This is ionic, and that is Na is sodium, and Cl is chloride. Sodium chloride. Back to covalent. So now there's two nitrogens here. So this is dinitrogen. Dinitrogen oxide. Now you could have said monooxide here. Usually the only time you see monooxide is when it's carbon monoxide. That's usually the only time you see it. If you had written it here, I probably would give it to you for full credit, but you don't actually have to put it there. And the last one, okay, this is where we get a little bit complicated. So NH4 is on your formula sheet. It looks just like that. NH4 is on the polyatomic formula sheet. It looks just like that. It's called ammonium. This is ammonium. Ammonium is a cleaner. You've probably seen it at the hardware store. Ammonium is usually sold under the name either ammonia or ammonium. It's a cleaner. You buy it. You clean. Your grandmother probably cleaned the bathroom with it. Most people use bleach nowadays, but ammonium is still available. Still a very good cleaner. So that's ammonium. Ammonium is +1. So ammonium is a cation. It is the only non-metal cation you're going to see. We don't do any more than ammonium in chemistry 1032. Okay, so if you ever see NH4 like this, that's ionic. Take it to the bank, that's ionic. Most of the time in 1032, 99.9% of the time, if you see a metal, it's ionic. If you don't see a metal, it's not, except for NH4, ammonium. Okay, so get that straight. NH4 is ammonium, it's +1, it's on the polyatomic formula sheet, so it's ionic. So this is going to be, and oh, sorry, I just kind of ignored phosphate. PO4 is a polyatomic, it's also on the formula sheet. It's called phosphate. So the name of this formula is ammonium phosphate. Ammonium phosphate. It is indeed ionic. If any of these problems gave you cause for concern, please pause the video, stop the video, raise your hand, go find a tutor, do something. Go find your professor. Get help with these problems. They're very, very simple once you get the hang of them. Okay? Please do not let these slide by. Don't ignore them. They're very important. All right? Please get help if you need it from one of the tutors here at the Academic Success Center. Now with that, I'd like to wish you good luck and good chemistry.